Did you know that nearly 99% of all liquid fresh water on Earth is stored underground? The Earth's surface is covered by oceans, seas, and rivers, but most of this water is saltwater. The small fraction that seeps underground supports over 2 billion lives every day. The Earth is full of porous spaces and cracks in the soil and rocks beneath the surface. When rainfall or melted snow seeps into the ground, they gradually move downward until these spaces become filled with water. This water saturates the underground layers of soil and rock, and is known as groundwater. The natural formations that hold and transmit this water are called aquifers. Groundwater plays a vital role in the water cycle and forms through a gradual process called infiltration and percolation, often referred to as recharge. It begins with precipitation. When rain or melting snow falls onto the land, some of this water flows over the surface, but a portion seeps into the ground via infiltration. As the water moves deeper, it slowly passes through layers of soil and rock in a process called percolation. Eventually, it reaches the saturated zone, where all the spaces are filled with water. The top of the zone is known as the groundwater table. Above the groundwater table lies the unsaturated zone, where soil contains both air and water. Below it is the saturated zone, where water fills the spaces between rock and soil particles. Most groundwater is stored in aquifers, which are natural underground formations of rock, sand, or gravel that can hold and transmit water. Aquifers come in two main types: confined and unconfined aquifers. An unconfined aquifer, also known as a water table aquifer, has its top layer open to the atmosphere through the soil, allowing water to flow freely in and out. A confined aquifer, on the other hand, is sandwiched between impermeable layers of rock or clay, which creates pressure. When tapped, water from a confined aquifer can even rise above the level of the aquifer itself, forming an artesian well. Groundwater supports life, even when rivers run dry. It provides base flow to rivers, keeps the wetland alive, and supports the ecosystem during the dry season. Groundwater makes up a larger percentage of Earth's freshwater compared to surface water. Groundwater and surface water are deeply connected. When the groundwater level rises, springs appear and feed rivers. And when rivers dry up, groundwater can replenish them from below. From farmland to urban water supply, groundwater is essential to human existence. It serves as a source of drinking water for over 2 billion people worldwide. Farmers depend on it to irrigate crops, industries use it in production processes, and urban centers pump it daily to meet municipal needs. However, our growing dependencies come with a cost. When groundwater is extracted faster than nature can replenish it, the groundwater table begins to decline, causing wells to run dry, the ground to sink, and saltwater to infiltrate freshwater zones, especially in coastal regions. To balance what we take from the ground, engineers may adopt techniques known as artificial recharge, allowing rainwater or treated wastewater to soak back into the aquifers. Some common methods include recharge wells, percolation ponds, infiltration trenches, and check dams. These systems help increase the groundwater table, especially in drought-prone areas, and ensure water availability for future generations. Groundwater table is also a key parameter in civil engineering designs. It significantly influences the safety and performance of structures. The level and behavior of groundwater can impact soil stability, foundation design, and the performance of underground works such as tunnels, basements, and retaining walls. If groundwater levels are not properly accounted for during construction, issues such as uplift pressure on foundations, seepage and leakage, soil instability or heaving, and even structural failure can occur. Therefore, conducting a hydrogeological survey to determine groundwater table depth and soil permeability is essential before any major construction. Groundwater can also become contaminated. Chemicals from fertilizers, leaking septic tanks, industrial discharges, and oil spills can gradually seep through the soil, eventually reaching and polluting aquifers. Unlike rivers or lakes, once groundwater becomes polluted, it may take decades or even centuries to recover. That's why sustainable groundwater management is vital. Though groundwater is hidden, its impact is everywhere, in the rivers we rely on, the food we eat, and the homes we build. Understanding how to manage it wisely is crucial for creating a sustainable future. If you found this information helpful, please like this video, share it with your friends, and subscribe and turn on the notification bell for more engineering and metallurgical content. Thank you for watching, and see you in the next video.